Yep, go ahead.
Are those people
Hello,
in the call the
everyone.
attendees or no?
We just double check everyone can hear us. Just put it in the chat. You should have chat access. Let's wait about 3 minutes just to double check everyone's getting on, and then we'll get going.
Are we live?
You are live.
Yeah. Connor, is the audio okay on the stream?
Testing audio, testing. Yep. Where's the audio? Okay, yep, everything's good. We're just gonna, this will be recorded for everyone's knowledge as well, and it might be used in the future. We'll start at 7. We'll wait 1 more minute just to make sure everyone gets on, and then we'll be good to go. And then after that, we'll open up a question period at the end of the session. If you have any questions during session, just add it to the meeting chat, and you'll be able to we'll be able to answer that. And yeah, your workshop facilitator Ash is on, and we are with Oleksandr Levinskyi, who will be happy to introduce himself. Go ahead, Alex.
Yeah, thank you. Cool. Like I'm assuming that everyone, like on Teams, everyone can see the screen as well, right? Just to confirm.
Everyone can see.
Okay, cool. Cool. Hello, everyone. Welcome to the GCP 101 workshop where we'll discover the power of cloud. So I guess before we start, I just want to briefly go over the agenda and explain what the goal of the session is. So after a brief introduction, we'll go over some cloud fundamentals, how we'll talk about how cloud is used, how we utilize, how we ML in cloud. We'll talk about ML in cloud and how cloud helps us with those, with ML features. Then we'll talk about common architecture patterns. We'll do a brief Google lab, and we'll also have an interactive quiz game, which all of you will be able to join. And also, I have a link for you with some credits that you can get from Google. You'll get like, okay, I'll talk about it a little bit later, but yeah, and then we'll have a Q&A session at the end. So the goal of this session is to essentially understand what cloud is and how it is applied, how it is used. And again, my assumption is that like you don't know what cloud is, or you barely know what it is. And again, hopefully by the end of the session, you'll have a better understanding of what cloud is capable of. Cool. So now I'll just briefly introduce myself. So my name is Oleksandr. I am a software developer and community leader. I used to be a Google Developer Student Club president at Conestoga College, and now I am a Google Developer Group lead organizer in Waterloo. And yeah, I have also worked on a few projects with Google Cloud, and I really like Google Cloud, and so I'm very excited for the session as well. Cool. Great. So now let's talk briefly about the definition and actually define what cloud is. So There is no, so if we are talking about cloud and computing, so there is no actual cloud. So cloud is not the one in the sky. So the clouds that you're used to have nothing to do with the actual cloud and computing. But essentially, like with simple words, cloud and computing is a vast network of remote servers around the world, which are connected together and are meant to operate as a single ecosystem. So essentially, cloud computing is the delivery of computing services like servers, storage, databases, networking, software over the internet to offer more robust and flexible resources. And again, it's essentially like there is no actual cloud. It's just someone else's computer, as you can see here. So essentially, various cloud service providers, they have huge data centers where they have a bunch of servers, and this is essentially what cloud is. Cool. Now, let's talk briefly about the benefits and key features of cloud. And I want to do it in comparison with the standard okay, and I will compare it with two server models. So essentially, like there are two primary options that you can use when you're like building a new application, right? And you want to deploy it. So either you can do deploy your let's say website either on premise, so like you would have your own server and you would like actual physical server and you would deploy it there, or you can use one of the cloud service providers like GCP, Google Cloud, and deploy your product there, right? So again, here I will talk about like again on-premise and cloud and compare the features of both. So let's start with scalability, right? So imagine you have a startup and you're developing a new application, and like you developed everything, everything's ready to go, and now it's time to deploy it and actually like serve it to the public. So you have two options, right? Either you can buy your own server, put it in the room, and then deploy the product there, or you can use like Google Cloud, for example. So scalability, with let's talk about that scenario. You deployed your application, and you like for the first month you had like 1,000 users, and imagine like after that first month, during one day you had like a huge spike in traffic and like million users visited your website. So if you have an actual physical server, it can be overloaded and it can essentially fail to respond to a bunch of users and you will lose a lot of traffic, right? But if you have your app deployed on cloud, then essentially cloud will offers that scalability and flexibility to scale the computing resources as needed, right? So for example, again, if you have a spike in traffic, cloud would make sure like to allocate more resources for your application, right? Whereas if you have physical servers, you would need to actually like duplicate the servers themselves, or actually buy the new service, right? Then about reliability. So your app's data is backed up on cloud. So if one server is down, the other one will take over and provide the same services. But if you have on-premise, so if you have the actual physical server in your room, if it goes down, like all the data can be lost and irretrievable. Yeah, and it's like again, you will not be able to recover it, and that can result in a lot of bad things. So again, cloud helps with the reliability as well. Then talking about performance, so there are regular updates to the latest technologies that are performed on the actual servers in the data centers, so by cloud service providers, whereas you need and again, it makes sure that cloud makes sure that you have the best performance possible. Whereas if you have on-premise service, so again, if you have a physical server, you need to do everything, like all the performance optimizations yourself. Talking about security, so, and again, there are enhanced security measures on cloud to protect data and applications. And also talking about cost efficiency, cloud reduces the cost of managing and maintaining IT systems, right? So for example, again, talking about the use case, the scenario I outlined initially, where we have like a startup and like you need to deploy an application, right? So if you don't use cloud, you can buy a server, but a server like costs what, $10,000-$20,000, and you need to spend it right away, right? But if and regardless of what how many users you have, but even if you have just a couple of users, you still need to purchase the whole server like to deploy it there. But if you use cloud, again, it will charge you only for those couple of users, which is like a few cents, or even probably even nothing. But again, if you scale, right, so you just pay as you go. So if you have like 1,000 users, cloud would charge you for 1,000 users, whereas again, with the actual physical servers, you need to have them like regardless, like you need to pay the fixed price for the server regardless of what your traffic is, right? I hope that makes sense. Then also cloud allows for advanced AI and ML integration. I'll talk about it soon, and in a few slides. And then also, I guess one of the main benefits of cloud service providers is they offer an entire ecosystem of services and products that you can integrate in your own app, right? So it's not just like deploying things, right? It's a bunch of, again, products that can be useful and integrated into your own applications and products, right? So cool. I hope that makes sense. Now let's let's move on to and answer the question, how is cloud used? So essentially, like as we discussed, like cloud computing enables businesses to leverage advanced technologies and infrastructure with minimal investment. But there are many ways you can use cloud. So there are many cloud service models, but here are like the most popular ones. So these four are essentially the four most popular ways how you can use cloud, right? The models, they're called like cloud service models that are the most popular. So those are infrastructure as a service, platform as a service, software as a service, and function as a service. I just, again, if you Google it, you'll see way more offerings and models, cloud service models, but those are like the biggest ones and the most popular ones. So let's go one by one. So infrastructure as a service is essentially when you rent online storage and servers. So essentially, like technically you rent someone else's computer, right? So on Google Cloud, you essentially rent a server, but like it doesn't belong to you physically. You just rent it kind of online via the internet. Let's put it this way. And then as an example, so again, cloud service providers like Google Cloud give service and storage on demand, right? So this is essentially what infrastructure as a service is. So like you are given infrastructure and it is sold to you, right, as a service. So now let's talk about platform as a service. So platform as a service allows you to develop and host applications online. So GCP is like one of the examples. It is more than just platform as a service, but it kind of encapsulates has that aspect to it as well. So GCP provides a platform for building, testing, and deploying apps. So you can use platform as a service to actually like deploy your own applications and develop them as well. Then we have software as a service. So this cloud service model is used to like for software that is provided over the internet. So like an example can be Google Workspace that offers tools like emailing, right, without installation. So you don't need to install anything. The app is running like on web, right? So this is essentially what software as a service is. And last but not least, we have function as a service, which is essentially when you run code in response to events without managing servers. So like an example can be cloud functions. This is like a service that is provided by Google Cloud. And with cloud functions, you can execute code in response to triggers like changes in data. So an example can be like imagine you have a you need to write a function that that like doesn't store anything in the database. It just responds to a certain event, right? So for example, imagine when you upload a picture, you need to run a function that would like minimize that picture and convert it into an avatar icon, right? So this is essentially what function as a service can be used for. So you can run that function for a certain task, and after the task is done, the resources are released, right? So function as a service only uses certain cloud resources only while it's running. It doesn't use them when it's not, when the function doesn't run, is not running. So those are like, again, this is an overview of some of the popular cloud service models. But again, like generally, to kind of summarize all this, like cloud helps you with quick deployment and testing, and also it helps you with global collaboration, right? And because various cloud service providers, they have servers and data centers all around the world. So like you can essentially host your, make sure that your users get reliable access regardless of where they are. So this is, again, hopefully that makes sense. And now this is just a, so this is a diagram that shows like the amount of stuff you need to manage depending on what cloud service model you use. So here you can see that, again, if you purchase, like, if you buy an actual server and put it like in a garage or something, so you can see here, so traditional on-premises, you would need to manage everything, right? So you would need to take care of data, application code, scaling, runtime, operating system, virtualization, and hardware. So you would need to maintain hardware, repair stuff, and stuff like that. And also to clarify, like essentially virtualization is creating multiple virtual machines on the server, like in simple words. Yeah, if you use cloud and specifically like some of the service models that we've discussed, then it becomes easier for you to manage everything, right? So if you use infrastructure as a service, if you use it as your cloud service model, and then you would just essentially cloud service provider would take care of hardware maintenance and virtualization, and you would need to manage everything like from operating system, runtime, scaling, application code, and data. But again, those two things like virtualization and hardware are managed for you. And then if you use platform as a service, then a cloud service provider takes care of hardware, virtualization, operating system, and runtime. But what you would need to do is take care of scaling and application code and also data. With function as a service, again, cloud service providers take care even of more stuff. And software as a service, you essentially, everything is managed by cloud service providers. You just need to take care of your data, right? Cool. Now, Let me see. Cool. Yeah. Now I want to talk about ML and cloud. And again, like if you have any questions on the previous sections, I hope like it makes sense what I was saying. But yeah, if you have any sections, any questions, then you can ask them at the end of the session. Cool. Now let's talk about ML and cloud. So specifically, like how Google Cloud can help you integrate AI and machine learning into your apps, or generally how you can develop ML products in Google Cloud. So essentially, Google Cloud offers scalable and flexible resources, making it ideal for training and deploying machine learning models. So these resources adapt to varying demands of ML workloads, ensuring efficient processing and cost effectiveness. So essentially, again, since ML tasks and generally building an ML product takes a lot of resources, cloud is a perfect solution because it is scalable and it helps you with all the infrastructure and all the infrastructure behind the scenes, right? So you just take care of the code, and essentially that's it. So generally speaking, cloud has been vital in AI growth. So the cloud provides extensive computing power and storage capabilities necessary for training and running complex AI models. And essentially all of the products or the most recent AI advances or in generally AI products, they were possible because of the cloud, right? Again, because of the reason that cloud is very scalable. But now I just want to talk about like a specific section of Google Cloud, so Vertex AI and what it is. So Vertex AI is an integrated ML platform that is so by Google Cloud that simplifies the process of building, training, deploying machine learning models. So essentially the whole like you can build an ML project from start to finish using Vertex AI. And I just want to give you like an overview of a few features on Vertex AI that you might find interesting. So the first one is called Model Garden. So if you go to Google Cloud, you sign up, and then you just search here Model Garden, you will be able to see like a lot of models that are already available to you, and you can easily integrate them in your application, right? So one example can be Palm 2 model, which is essentially a similar model that's provided by OpenAI, GPT, right? But Palm is a model that was created by Google, and it has like similar functionality. So like here, if I click, so I go here, again, you just view details, you open prompt design, and here you can actually like play around with it. So let's, and again, it's essentially like this model allows you to build like a chatbot or like answer questions based on the data, on certain data, right? So for example, if you have like a document, you can upload it. You can upload it in the context. I think it's here. Yeah, in the context under structured, and then based on that context, your this model will be able to answer questions that you ask, right? But here, like, but also it can act like as a similar to ChatGPT. So where you can say like, so what is cloud, right? And then if you run it, you can see that it says a cloud is a visible mass of liquid droplets or frozen crystals made of water or various chemicals suspended in an atmosphere above the surface of a planetary body. So essentially, it's just the usual I guess, definition of cloud that most of people are used to. But there are also some configuration options. So one of them is temperature. And essentially what temperature is, it's if the temperature is lower, it gives you more like truthful, or let's put it correct, well, yeah, more truthful responses. Whereas if the temperature is higher, it gives you more diverse or unexpected results, right? So right now it's 0.2, but if I like decrease it and I set it to 0 and I click submit, you can see that it gives a completely different definition. It gives the definition of the cloud and computing. So again, you can play like with temperature a little bit. There are a few other things like token limit, and you can read more about those here or on the documentation, GCP documentation. And yeah, essentially this is like one short demo of the Vertex AI. What Vertex AI has is just like one little thing that it offers, right? So, but here there is also a generative AI studio where you can quickly test and customize generative AI models to leverage their capabilities in your applications, right? So, and there are different categories like language, vision, and speech. So again, you can play around with those things on your own. Click buttons. So again, either go to Model Garden, explore different models, right, and see what you can do with them. So again, some models, they already have like a UI for you to play, but some models you actually need to deploy them. And actually, one more thing that I forgot to show you, you can easily integrate this Palm 2 model into your own application. So with the help of this option, so view code. So if you have a Python server, this is so it gives you the code that you can use to integrate Palm into your application, or you can use a curl request, which is essentially like how you can make, so you can make simple API calls as well. And yeah, you can see the API call structure here. So it's pretty, so again, you can use either an API or actually write some code on your server and like create API endpoints, your own API endpoints. So that's, again, briefly about Palm 2 and the Model Garden and Vertex AI. But also there is a very cool product called MediaPipe. So MediaPipe is another tool that's developed by Google, essentially to simplify developer experience. So here you can see it's mostly focused. So this MediaPipe Studio is mostly focused on vision, text, and audio. So, and here, like a lot, here you can see a lot of demos of various products. So here's like one, right? So this one is a hand landmark detection, right? And here, essentially, so this model helps you. So it's already developed, right? You can see it works on my camera, and it detects like the movement of your hands, and it's pretty accurate, as you can see, right? And I was just thinking, like, before the session, I think it would be very cool to build like maybe a portfolio project with it, right? So again, you can use Google Cloud to deploy this model, and then use it on your in your application, and essentially like you can develop a game or something that would like detect your hand gesture and then do something, right? So it would be a very visual and cool project, because I know a lot of students have asked me like what they should build for their portfolio, and I think like integrating some of those ML like AI products would be very cool, because again, it's very visual and fun. Then there are, so this is hand landmark detection. So there is also object detection. It's not very accurate, but like, so you can see 80% people, if I put bottle, it can detect a bottle. Then, so image classification, sunglasses, lab coats, okay, whatever. Then there is also segmentation. So essentially just outlines the, like in this case, me. Then what is this interactive 10? So gesture we did. So, or I guess gesture. So here it can detect, you see thumbs up, thumbs down. It can detect like victory sign, a fist. Then what else? This thing. Yeah, I think waving. Okay, but it doesn't. Okay. It can detect an open palm. Great. Then there are also, what else? So face stylization. So what it can do here is like you take a picture, and then it kind of creates a color sketch of it. It's not very accurate. It doesn't look like me at all, but still, like there are other options here. And then face detection. So it just, again, if you have an application that it needs to detect like faces, right? This is a good model to do that. Then face landmark. So here, this gives you like an outline of your face, right? So here you can see like the eyes, the brows, and it's pretty detailed. The mouth as well. So again, you can use it as well. And I'm not sure what this one is. And yeah, here it just face and hands as well, but or generally the body. You can see my shoulders. Yeah, so that's those are, again, that's a pretty cool thing to play with. And again, you can use GCP to again either deploy those models and then serve them, so you can use it in your applications. So again, that just oh, I stopped sharing my screen. Yeah, those are just some of the use cases, right, where cloud can be useful in the ML space. Cool. Now let's move on and briefly talk about cloud architecture patterns. So essentially in what scenarios cloud can be useful. So just a few like architectures that we'll review. So microservices is the first one. So essentially microservices are, it consists of small independent components, so services, that communicate via APIs. So essentially, like it's a bunch of APIs communicating together. And essentially, the way cloud helps with it, it can, again, scaling, right? So if one service is heavily used and it needs more resources, it would be duplicated, right? So you can use Google Kubernetes engine for that, or again, other products and services provided in Google Cloud. And again, an example can be a retail website where inventory, users account, and payment processing are separate services. And again, so for example, you know, like it's like Black Friday and there are a lot of payments going through, right? And payment processing services heavily used, so you would allocate more resources for it. And then user accounts and inventory services are probably not as heavily used, so that's why you would scale them down. Well, payment processing services would be scaled up and replicated. So again, this is essentially how Google Cloud can help you. Then, or generally any cloud service provider, then we have event-driven architecture. So, and this is an architecture where services react to events or changes rather than following a strict request or response pattern. So again, it can be, you can attach like various, like react to various events, like maybe using, I don't know, PubSub, right? So when something happens, you would execute something else, right? So we were, so I'm just trying to think of an example. So an example here, an IoT system where sensor data triggers specific actions in cloud. So again, for example, if a sensor detects certain activity, it would trigger something in the cloud, right? And again, these types of applications can be developed using cloud. And also serverless architecture is when So this is an architecture where you run application code on demand without the need of to manage service or infrastructure. So that was like an example that I had given before. So a photo processing application that resizes images uploaded to a cloud storage, and then they're only triggered when new images are uploaded, right? And then it would so in that case, I gave you an example of cloud function. So a cloud function would be an example of I don't know, like a serverless architecture where you essentially again, you use resources only, cloud resources only where when a function is running. So again, those are like just a few examples of again, use cases and some architecture patterns and like how cloud can be used. I know it may sound like a bit complicated or confusing, especially if you've never like heard of microservices or event-driven stuff. Yeah, that's no worries if it sounds confusing. Hopefully, again, when you get more exposure to certain applications, you will understand more. But yep, I think now it's time for the lab. Cool. So I will share also like some resources, and also will complete the lab for you now. So essentially, I will do one lab, and you will just like look at me completing it, and like watch me doing it, and then after this, I will explain how you can get credits and actually get access to those resources. So you can again complete those tutorials yourself. So Google so essentially there is a learning resource that's very useful, that's called Google Cloud Skills Boost, and it essentially helps you. It's designed to help you prepare for like learn more about the cloud, including like from scratch, and also prepare you for Google Cloud certifications. So here there are like I think 15 or something paths, or even more. I think it looks more, like more. But essentially, you can like select like what you're interested in, right? So for example, there is one path for beginners that I think. So Google Cloud Computing Foundations. So this is I think the one that we'll do. We'll do just one lab from it, but it has a lot of videos. It has a lot of let's see. Yeah, so here, if I click on this course, Cloud Computer Foundations, you can see it has a lot of, so each path has courses, and when you complete a course, you earn a badge, and then you can display those badges like publicly and share it with everyone essentially. But again, I suggest like you start with, if you're new to cloud, I suggest you do this path. You complete this path first and do all of the courses here. And again, it has mostly it consists of videos, so video tutorials and hands-on labs. And also it has like some references. So if you're interested, you can look into them as well. But again, it's pretty comprehensive. So this one again is just for beginners, but there are a lot of other paths that you can explore. So one that I was interested in and still am interested in is the machine learning engineer learning path. So there you can learn more about like how to build and deploy models with the help of GCP and general like AI offerings. There is also in GCP, and there is also a generative AI path, I think. It was added recently. Yeah, here, Introduction to Generative AI Learning Path. So you can explore that as well. But there are also some other paths like, where is it? So Cloud Architect. There is also, what is this? like networking, DevOps, like MLOps, and data analytics, and stuff like that. So again, you can pick a path that you're most interested in and complete which videos and tutorials there. Then we have a cool. Yeah. So now, just as an example, I'll complete this lab with you. Cool. So it is essentially a part of the Google Cloud Computing Foundations course, and there you can find a lab, this lab. But again, I will share the link with you, and you will be able, like a special link with you, and you will be able to get some credits to complete the labs, because some labs are free, but some labs are paid, and you pay for them using credits. And usually you need to purchase them, those credits, but I will give you, like with the link that I will give you later, you'll be able to get some credits and complete some paid labs, right? And some courses that you're interested in. So, but again, here we'll just an overview of Google Cloud Skills Boost. I will complete this hands-on lab, just like a tour of GCP. So here, essentially what you need to do, like, I will not like read everything. It says 45 minutes, but it like 5-10 minutes is more than enough to complete it. So it essentially like explains what Google Cloud Skills Boost is, what GCP is all about, and stuff like that. So let's start. So I think like it also explains like how the labs work, but essentially like to start the lab, you need to click this button. You need to verify that you are not a robot, which I always fail to do for launching this. The payment if you start this lab. Okay, I guess I just completed it too many times. So that's why it says it's the last time you can do it for free. Great. So essentially, after you click Start Lab, the timer starts. And what happens is Google Cloud Skills Boost, it allocates resources for you to play around with on Google Cloud. So you cannot do whatever you want, but you can follow the tutorial with as part of this lab and do what this lab is teaching you. So in this case, it says, so test your understanding. So each lab has essentially some quiz questions and to track your progress through the lab. And you will see some more fancy features later. But here is like one. So it asks that like Google Cloud Skills Boost builds a temporary environment in Google Cloud. Or I guess, no, this builds a temporary environment in Google Cloud. So what builds it? It builds like a start lab button essentially does this, right? So when you click it, there are certain resources are allocated for you to complete this lab, right? And after the time expires, so when the timer reaches 0, you will lose access to your temporary Google Cloud environment, which is true. Then some labs have tracking, which scores your completion of hands-on lab activities. So we'll see that feature a little bit later. So essentially, those hands-on labs have a feature when you like do something on Google Cloud platform, you would just click check my progress, and it would say either you completed that step or no. Again, you will see it later, I guess, in step 4, in task 4. But here it says, so the answer is true. And then in order to receive a completion credit for a lab that has tracking, you must complete the required hands-on lab activity. So that's true. So essentially, like to complete a lab and to get a credit for this, you need to complete it fully, right? And answer all the quiz questions and track your progress. So now let's briefly, I will briefly explain like what this stuff is. So here on the left pane, panel, you have a button which is Open Google Cloud Console. When you click it, you will be redirected to this screen, and you should use your username that is given to you here. So you copy this username and go to go there, click next, and then you use that password that was provided to you here as well. Do not use your personal account because it will charge you. But if you use this account, it will not, right? Because it's part of the lab. So again, here I just enter the password. You click I understand, agree to all the terms and conditions. So you click agree, select the country, agree and continue. So here, this is essentially Google Cloud Platform. So here you can see all the services, right? So that are available to you. Then here it says, so yeah, here it just explains that you need to use another account, and it is very important that you do that. And then what else does it say? Yeah, also it gives you like a project ID that is created for you on Google Cloud Platform, and then you can reference it again in your hands-on lab if it asks you to, right? But here it just again tests your understanding. So what field is not found on the left pane? So you can see that there is password here, there is project ID here, there is Open Cloud Console button, but there is no like system admin option. So this is what is not found there. Sorry. And then the username in the left panel, which resembles like an email address with an extension of quicklabs.net, is a cloud IAM identity. I will talk a little bit more about it later, but essentially it is. So let's see, maybe I can find some explanations here. So yeah, here it says that username and password. So these credentials represent an identity in the Cloud Identity and Access Management Service, which is called Cloud IAM. And this identity has access permissions that allow you to work with Google Cloud resources in the project you've been allocated. So here we can say that, so the username is a Cloud IAM identity, so we click true. Then projects in Google Cloud. So here, I guess, here you can see all the info about project, right? So you can see project name, project number, project ID. So again, you often, so later, if you build something with the cloud, you often reference those credentials in whatever you build to connect it to this Google Cloud project. But so this is a very useful widget that they put here. Then it says, so an organizing entity for anything you built with the cloud. So let's see. So it should be, so you can see the answer is here. So a Google Cloud project is an organizing entity for your Google Cloud resources. It often contains resources and services. For example, it may hold a pool of virtual machines, a set of databases, and a network that connects them together, and stuff like that. So, so the answer to this question is Google Cloud Project. Then Quick Labs resources is shared read-only with all Quick Labs users, which means that you cannot delete or modify anything like on that project. So, for example, if this so if this project has a virtual machine created, you don't have permissions to delete it because this is essentially how hands-on labs work. But if you were to create them under your account and you would be an administrator for that or an owner for that project, you would be able to manage all the resources freely. So here you just say true. And then Quick Lab Resources is the project where you run all of your lab steps, which is true, which is false. Why? Quick Lab Resources is the project where you run all of your, okay, no, it's false because you run some of the lab steps in the actual cloud console, right? So that's why. Great. Cool. Now they just talk briefly about like the navigation menu. So here they explain that here this like burger menu, when you click on it, you can see a lot of products and services that you can GCP offers. So if we click more products, you can see that there are compute services, there are serverless services, there are storage services, databases, integration, networking, operations. Yeah, a lot of different things, and it's so you have a lot of things to explore and to learn. Yeah, but essentially, like this is what they say here. And then in terms of roles and permissions, so here they just explain to you what roles and permissions are. So if we go here and go to IAM and admin and click on this first option here, you can see that this is my account, right? So this is the email I used to log in. That's an email that was generated by Quick Labs. And here you can see that I have an editor role for the project, and I have a viewer role, right? So I can view some resources and I can edit some resources, but I don't have full access to the project as part of this lab, just because this lab is shared with other people as well. So that's why they don't want you to delete stuff. Cool. So, and here they just explain different roles. Viewer is that you have read-only permissions, so they do not affect state, but you can so you can view certain resources, right? Then you have editor role, so all the viewer permissions plus permissions for actions that modify state, such as changing existing resources. And then owner, it's like all the editor permissions and permissions for the following actions. So manage roles and permissions. So you can add more roles to certain users and grant them certain privileges in the project, and all resources within the project. And then yeah, also you can set up building for the project, and generally like you have full access and all the capabilities and all the offerings, you have access to them if you are the owner of the project. Cool. So here they say offers. So what offers quick access to platform services and also outlines its offerings? It's the navigation menu. And then basic roles, set project level permissions, and unless otherwise specified, control access and management to all Google Cloud services. That's a very good question. Unless otherwise specified, control. I think it's true. Okay, great. Yeah, because with the help of roles, you essentially set the permissions, and then yeah, provides all viewer permissions plus permissions. So yeah, what role provides all viewer permissions plus permissions of for actions that modify state? So the answer is editor role. Crazy. I just realized that it's 53 minutes already. And then, yeah, let me do it quickly. So here they just teach you how to enable API services. Oh, crazy. I realized I didn't share this thing. So this is what I was doing. Here you can see that, yeah, this is just some answers to the quiz questions that I was speaking about, but you can see it. But also there is one last step of this lab is where you actually need to enable an API service. So let's see. It takes a while to load, but cool. So here, if I click like an API, so essentially in your so Dialogflow in your project, you can enable many external APIs and other services. So here's a dialog flow, which allows you to build conversational interfaces and chatbots. So here I enabled it, and if I switch back here, I click check my progress here, and you can see that the lab checks that marks that I completed the step, and it gave me 10 points for completing this. So testing and understanding, when you start a lab, you need to enable APIs in your project. So here the answer is false, but yeah, cool. And then at the end, you just, after you do everything, you end the lab and you submit. And after this, you can just share some feedback, but this is essentially how the labs work. Cool. Now, let's just quickly go through, very quickly. So GCP roadmap, you can complete, with the help of those cloud skills boosts, you can complete you can prepare yourself for certifications, and here are like some of them. So the basic, like, I looked it up and it seems like the most basic one. So cloud digital leader, then you have cloud engineer, and then you have more like professional side of things where it's cloud architect, data engineer, machine learning engineer, cloud DevOps engineer, so MLOps, and stuff like that. So yeah, this is just some roadmap. And now finally, let's, we are a little bit late, but let's do this quick game. So I will launch it, and if you use this code to join, actually give me a second, I need to start the game first, but yeah, so if you, cool, questions? Oh, crazy, let me.
Can you add it through Teams, Alexander?
Yeah, I will do that. Okay, I see one player is there.
So if you hit the plus apps, just hit Mentimeter, and then you can add it right to the meeting.
Plus apps.
Plus apps, and then click and then search for Mentimeter.
I think it might be, I cannot find this thing, but maybe what I'll do is I'll just share a link that's like in the chat here. So yeah, you can use this link to join the same game. And let me see, cool. Okay, 2 people. Do we want to have more players? Cool. Let's wait maybe a minute or so. Essentially, all the questions are related to what I explained like during the presentation. I know that like the lab took a little while. I probably should have shortened it a little bit, but yeah, let's try to quickly play that. Okay, let's do one more person, someone else. So at least we have 5. Okay. Anyways, let's start. Great, 5. Cool. So the first question is, what is cloud? So you have 15 seconds to answer it. So cloud is an internet-based computing services, physical server and office, local data storage method, personal computer system. Cool. So yeah, cloud is an internet-based computing services. So it's a physical server, but not in your office. It's essentially, it's a bunch of physical servers that are in a different location. Cool. Now let's move on. Cool. So this is the leadership board. Then we have, let's move on. So the next one. Why would you use cloud over on-premise service? So essentially, why would you use cloud instead of having a physical server in your garage or something. So greater physical control or upfront costs, requires more space and limited scalability. So lower upfront costs. The reason is that, again, for the physical server, you need to pay for it right away. So if it costs 10,000, you need to purchase it right away. But if it's cloud, you just pay for what you use. It can be like a few cents or a few dollars. So it's pretty cheap. Cool. Great. Now, next question is, what cloud service model does Google Workspace utilize? Infrastructure as a service, platform as a service, software as a service, and function as a service. So it is actually, so Google Workspace is a software as a service, just because like Google Workspace is essentially online software, right? So that's why it is software as a service. So yep, one person got it right. Then I see more people join. That's good, but we just have one more question left. Great. Let's continue. So what is Vertex AI? So it is a cloud storage service. It's an ML platform, Google data analysis tool, or a computer networking service. Cool. Yeah, it is an ML platform that's offered to you by Google, Google Cloud specifically. So yeah, cool. So that was the last question. And the winner is Ashton, then Connor, then Game of Thrones. So congrats. Thank you for participating. And yeah, last thing, I guess I just do Q&As. And yeah, generally, thank you for being here. I'll be happy to connect on LinkedIn, or you can contact me on my website as well. But yeah, that's all from me. So Connor, you take it away. Sorry, I'm not sure if you said anything because, yeah, but essentially, like, again, if there are any questions in the chat, or yeah, you want to ask something, some clarifications, then please let me know. Also, yeah, I wanted to share this link with you. Give me a second. So for all of you, you can use this link to get, so it will give you 9 credits. Yeah, thank you.
I gave them 200.
You gave them 200?
So they just have to request it from the education one, and they get 200, and then I might move some. I have a couple thousand left as well that I might transfer over. I just left it as is for now.
Okay.
But yeah, if you got a link, for sure, share it with them.
Yeah,
as much as we can give out.
Yeah, I just dropped it in the chat. It gives you only 9 credits, but after you complete the introduction, I think, yeah, you need to. Generally, for those labs, I suggest you use an incognito window, because it can mess up with your like generally with your browser accounts, Chrome, yeah, Google accounts. So it's better, like, when you complete a lab, just open an incognito window and do it there. It's just like a suggestion, but again, as Connor said, you can, if you have like 200 credits, that's great. You can complete a lot of labs with that. So yeah, cool. Do we have any questions? Or I guess the lab was.
We had a few that were provided for the event. If we could go through them quickly.
Sounds good. Yeah.
You just put them in the chat for you. Okay, they're in the chat. If we can get And maybe once you provide the answer, maybe we can summarize it in the chat as well, just so they can see it as well. Thanks.
Yeah, sounds good. So how can I use Google Cloud certifications to maximize job opportunities in the tech industry, and which ones would you recommend are worth my time? Should you many of them? Like generally speaking, like I think you should start like with start with at least like fundamentals, and then yeah, just um, move forward. Because like I know people like they just start again with basic certifications, and they just little by little, they learn more and more aspects of the cloud, and they just pass certifications for those sections as well. So it's again, it just probably with the basics first, and then yeah, learn the basics first to understand how it works, at least conceptually, and then try to build some stuff with the cloud. So try to deploy some services on the cloud, try to build some ML projects with the cloud, because it's just a very cool and interactive. It would be a very cool and interactive portfolio project to have if it's like ML related. And then in terms of like generally certifications, so certifications will be like relatively, I think it's very hard like to pass a certificate, like, okay, technically you can pass certification if you just memorize the answers, right? But generally speaking, like after you have a few years of industry experience, it will be easier for you to do that, just because you've had, after a while, you would get like certain experience and exposure to various services and on Google Cloud and various use cases, various scenarios, and it will be yeah, and it would be easier for you to complete the certification. But again, like in turn, maybe if you're asking about like should you focus on GCP or other cloud service providers, again, it probably like GCP would be a great option to go with, because like you have a lot of learning resources, right, that are provided to you for free. But generally speaking, like if you have a company that you want to work for or something, then you would you can also target a cloud service provider that they use, right? So if they use GCP, then GCP would be a great option to go with, right? So to learn, and then during the interview, you can say that you've had exposure and experience to some cloud services and products, and yeah, it just gives you more value as a professional. Then what is the roadmap for to become a cloud engineer? I guess like generally speaking, like I would say just start with something small, complete a few labs, like get the gist of what the cloud is, and maybe an overview of basic services that are very common. And then, yeah, little by little, again, you can grasp those aspects, right? And then you can actually, like, again, I just suggest you do like side projects, try to play with different services, and also complete the labs, right? That we shared with you. Select the path or something to yeah, and complete all the labs and learning resources there, and can help you a lot with in becoming a cloud engineer. And then what to answer when asked about how you handle that situation. I'm not sure what you mean, what this question is, but yeah, maybe if you can elaborate a little bit. But the next one is, what would you recommend to do in order to stand out in the massive and ever evolving? Yeah, it's very hard. I can tell you that. It definitely, like, again, requires a lot of effort, and I guess also imagination. But like what I would say, like create a project with something like this, right, where you can use gestures or something. It would be very cool because it's very visual, and it it uses cloud concepts. It uses you would use like GCP. You would deploy a model. You can also integrate a lot of UI components, right? You can have your own backend. So it's like a pretty comprehensive project that you can build. So and it will. So if someone had built a project using the gesture detectors, or it's something fancy like a game, then it was like for a co-op role, then I think it would definitely be beneficial and help you stand out. So, yep. So, cool. I think that's all the questions. Unless there are more, I think I can. I just thank all of you. So Sheridan for having me, and GDC Sheridan for having me, and all the attendees for attending. And yeah, I hope you enjoyed. I know that the lab was a little bit long, but yeah, hopefully at this point, like you understand what cloud is, what you more or less can do with it, and you also understand where you can learn more about it. So you have the next steps. Cool.
Thank you so much, Oleksandr. If anyone did have any other question that they wanted to answer, just raise your hand and we can turn your mics on as well.
Cool. Yeah, I think, again, as I said, you can just contact me on LinkedIn or via my website. But yeah, that's it, I think, for today. So thank you so much.
Thank you so much, Oleksandr, and thank you to everyone for attending today. And we look forward to the next event. Thanks so much.
Bye-bye.